Hey, here we go. Part B. Same thing, guys. I'll just go through each one of these questions. Again, some of these were pretty easy, I think, the score wise. Y'all, like everybody did well on, and some of them were not. So I'm going to either assume they were hard, or I'm going to assume that I did not do a good job on that question. One of the two. Typically, when you got three classes, so you got a random sample of 63, 64 kids, and if more people missed it than got it right, that's either a hard question, or it's a me question. I didn't do a good job. Either way, let's fix these 15 questions right here. I go through them. Here we go. Study report: 75% of the young adults social believes that it's greater than 75. So therefore, which of the following is the most appropriate method? We believe it's greater than 70. So this is a Z test, one sample Z test for the difference. Nope, not for the difference. There's only one sample, so it can't be a difference. One sample ZT test for the sample. It's never a sample, never a sample. One sample Z test for the population proportion. I think that's what it is. Two samp. It's not two samp, two samp. We're going with C. Next question. Community service. A study reported that 28% of middle school students in a certain state participate in the community service activities. A teacher believes that the rate is higher than 28% for the middle school students. The teacher selected a random sample of middle school students. A percent of those students in the sample participating in community relations was found to be 32%. Which of the following is the most appropriate method? Okay, so Ho is 28. Ha is greater than 28. Two samp? No. One samp Z test for the sample? Nope, never a sample. One samp Z test for a population proportion. Okay, so if there's anything we got out of this, hopefully we recognize that this shouldn't be done with samples. Okay, everything's done into the population. That's what inference means. That's the definition. Number 3. Well, I know that A's wrong, and I know that B's wrong, and I know that C's wrong. So I don't even know what the question is. Worker representative factory believes that more than half. Which of the following is appropriate hypotheses? More than half? Man, I'm going to say that every one of y'all got that right. I didn't look that hard at what you got right and what you didn't, but reject screens. A manufacturer of cell phones concerned that because 12% of the screens. Oh, so this one's wrong and this one's wrong. So we're up to here, but here's 12%, 6%. Concerned because 12% of the screens produced were rejected, the final will be sold. A new processor introduced to see screens after the process several weeks. 100 of the 106 are rejected. That's my sample. 6% is my sample. So it's not going to be that. It's my 12%. What perceived? C was concerned because 12% of these final expression, a new process is introduced intended to reduce the proportion of rejected screens. I think that's what we're trying to prove. Let's check that one, make sure. A. Yep. Okay. A. All right. Number 5. A one sample Z test. They say it almost like we do, right? For proportion is conducted. Which of the following conditions checks the sampling distribution of the sample proportion is approximately normal? It's rejected. The sample is random. That doesn't test normality. N times P greater than or equal to 10. N times, that one checks normality. The sample size is less than 10%. That doesn't check normality. So it should be 2 only. Okay, now 1, 2, and 3 are the conditions we need to proceed on to the test or to the interval or whatever we're doing. But to check normality, I only need number 2. Surely that's right. B, yeah. Yeah, we need that sample size to be sufficiently large. Social media, number 6. A newspaper claims that 92% of the teens use social media. To investigate this claim, a poll organization selected a random sample of 100 teens. 96 indicated that they use social media. Given this data, why is it not appropriate to use a one sample Z test? Random sample, so we're good there. The random sample. No, it's random. The sample is more than 10%. Well, I don't think that. We think that this one's never true. The observed number of teens who do not use was less than 10. No, the observed number is 96. The expected number who do not, hold on. The observed numbers who do not use the distribution of the population is not normal. That's bad. We don't care about the population. We care about the sample. I think it's this one. The observed number of teens who do not use social media is less than 10. To investigate the claim, 96 do. I think that's C. No, it's D. Dang it. Checking the expected numbers. Okay, so let's clean that up, I guess. The observed is the 96. And then so the expected who do not would be the 4. I could see easily why you missed that one. I missed that one. That happens. That's a tough one. I get that one. That's tough. I don't know if I like that observed and expected. We do a lot of that observed and expected stuff in chapter, what did we get done with? 12, 13, 14, and chapter 15, but we don't have to do chapter 15. That's not on your AP test. Bullfrog population. A state biologist investigated the proportion of bullfrogs or frogs in a certain area. Bullfrogs has increased over the 10 years. The proportion is estimated to be 20%. So there's my ho and there's my ha. We think it's greater than. A recent sample of 150 from the 36. Biologists conducted a test of this. Which of the following is a test statistic? So it's all Z's. That's good. It's proportions. It should be P. Let's see. Sample minus parameter. Sample minus parameter. So this should be the 20. So it's one of these last 3. And it's not this one because the entire thing's not in the radical. So this one, and see, boy, that's hard for me to see, guys. That's 24. No, this should be this one because it's P hat minus P, and it's P1 If you know what P is, use it. That one should be D. Let's get my confidence built back up. Yeah, D. D. Number 8. Hypotheses test was conducted to investigate whether the population for a certain movie theater was greater than 2. A random sample of 100 students. Test statistic of 2.25, assuming all the conditions were met. Which of the following is closest to the p-value? All right, let's see. Is greater than 2. That's my test statistic. Greater than 2. It's a normal CDF because it's a Z. 2.25. It's right there. 2.25 to 99999 because it was greater. .12. 0.122. Looks like B. If it was a 2 sample, we'd put C. B. Okay, good. 9, a positive, or A positive. Huh? A positive. A positive. What's about blood type? A positive. Oh, okay. That's what I am, A positive. In the United States, 36% of the people have type that's A positive. So I'm part of that 36%. A random sample of 150. From Norway, 66. So 66 out of the 150 in Norway. Consider a hypothesis test to investigate the proportion of people is different from the United States. So that's a 2 sample. Which of the following is a standard deviation used to calculate the test statistic for the 1 sample Z test? I need P right there. 36%. That's what HO is. HO, P equals 0.36. We think it's different than 0.36. So we want 0.3. That's it. That's got to be it. I think that one's got to be it. Yeah, C's right. P equals 0.36 because that's what the United States was. That's what we're comparing Norway to. You'll find you're not going to use a calculator very much. I left the answer up there. Molly works for a meat producer. She needed to determine the producers have correct fat content. She takes a random sample 120, finds an 84%. Molly then conducts a hypothesis test, equals 0.8, not equal to 0.8. Test statistic of this with a p-value of this. Which of the following best represents the meaning of that p-value? This is one of those definitions that we don't use a whole lot of, but AP likes to use it. So this is one you really need to know what that p-value is. A p-value is the chances. It's a proportion. So there's a 27% chance. There's a 27% chance of getting the sample that we got, assuming this is true. That's what the p-value means. It's the chances of getting what we saw or what we got, or the z-score. It's the chances of getting that z-score. It's the chances of getting that p-hat. It's the chance of getting that x-bar. It's the chance of getting the sample. It's the chance of getting that difference of that samples. It's the chances of getting that, assuming Ho is true. If the population proportion is 0.84, that has nothing to do with this. The probability of getting, no. We're trying to assume that the population is true. If the population proportion is 0.80, the probability of observing a sample proportion within 0.04 of this is this. Okay, we think it's different. So let's kind of look at the picture here, right? 0.8. We think P is not equal to 0.8. So I'm concerned with this area and this area. Okay, if it's outside of there. If the population proportion is 0.8, the probability of observing within 0.04. No, it's not within that. It's not within that. It's not this area. It's outside of that. Okay, it's outside of that. If the proportion, the probability of at least greater than. No, I don't like that one either. That's if it was a greater than test. If the population proportion is 0.8, the probability of observing the sample proportion of at least 0.84 or at most 0.76. That's what I like, because this is the 0.76 and this is the 0.84 of getting it higher than that or lower than that. If the population proportion is 0.8, which we assume that to be true, the probability of getting at least 0.84 or at most 0.76, so it's less than this and it's greater than this, is 0.23. That's got to be the answer. And that was. I left the answer up there on that. Okay, 11. Chicken hatcheries employ the sex of the baby chicks. Hatcheries claim that the workers are correct 95% of the time. Ho, P equals 0.95. An investigator believes the worker's success rate is actually less than, P is less than 0.95. The investigator selects a random sample of chicks and finds that the hatchery workers had a success of this. So there's my p-hat. The conditions for this inference were checked and verified. The p-value was given at this. If the null hypothesis is true, what is the following statement is a correct interpretation of this p-value? Of all possible samples of the same size will result in a success rate of this or less. We thought it was more than, didn't we? Oh, no, we thought it was less than that. There's of getting this or less. I kind of like that one. If all possible samples of the same size, will result in this or more. I don't think we did less, didn't we? Where's that at? Yeah, less than. So I don't like this. Of all possible samples, there's this percent of 95% or less. No, that's in the middle. That has nothing. It's getting the sample. This is my sample. Yeah, I think I like that. A. Yeah. These are tough questions. I don't harp on those. I'll take a lot of blame for those too. I'll take a lot of blame for those. I don't do a whole lot of that. I think I did the first one, and then I didn't harp on that p-value very much after that. That's important for us to know, is that p-value, what it's actually telling us. True for p-values. Now I'm starting to see why we didn't do as well on these. In a hypothesis test for a single proportion, which of the following is assumed to be the calculation of the p-value? In a hypothesis test for a single proportion, which of the following is assumed? Oh, which of the following is assumed for the calculation of p-value? No, that's not true. The null is true. That's what we have to assume. Assuming the null is true. I think that's the definition we use. The probability, the p-value is the probability of obtaining the test result we got, assuming holds true. Yeah, that's got to be it. We have to do this one to do the test, but that's not the correct for the p-value. For the p-value, we have to do this to make sure it's test. That's got to be B. Yeah. All right, 3 more, guys. Hang with me. 13. A major credit card company is interested in a proportion of individuals who use a comparative script. There's the null. Got a sample of this, which is higher. The p-value is this. Is there convincing statistical evidence at the 0.05 level? So we're greater than. So I'm going to have to say no, because we're greater than. We have to fail to reject. So there's not evidence that is greater than this. Okay? Yes, yes, no, because the sample proportion is greater. No, that has no, since the sample, no, because the p-value is greater. Yeah. I hope you got that one. Maybe put yes, but hopefully no. It's not statistical evident if it's greater than. It is statistically significant if it's less than. We're good there? Yeah, E. 2 more. 11:18. Got to quit doing this so late at night. A book club wonders if fewer than 40% of the students to test the claim the books in the local university recorded students got Ho P is equal to 0.4. We think it's less than 0.4. P-value of 0.03, assuming all the conditions were met. Which of the following is an appropriate conclusion? What's my conclusion? All right, at 0.01, 0.03 is greater than. The null is rejected. Nope. At 0.01, we're greater than. Reject, no. At 0.01, the null hypothesis is not rejected. There is not. No. If you fail to reject it, then there's not enough evidence. It's all the bigger words, right? Greater, fail to reject, is not. That doesn't work. 0.05. Now we're less. It's rejected. There is convincing. I like this one. At the 0.05, it's rejected. There is not. No, I like this one. D. They like that one too. I like it when we agree. 15. Is the significant level of hypothesis test equivalent to the probability that the null hypothesis is true? Made you dig in your head on that one a little bit. What significance level is alpha? Yeah, alpha. Alpha is also what? The probability of committing a type 1 error. Is a significance level of a hypothesis equivalent to the probability that the null hypothesis is true? Type 1 is, what do? That's when you reject a true null. No, the significance level is the probability of rejecting the null when the null is actually true. I like that. Yes, the significance levels of the null is actually true. We can't ever say that the null is true. No, rejecting a null when it's false. No, when you reject it, we think it's false. No, failing to reject when it's true. No, that's like a no. I like A. Please tell me that's right. Yeah. All right, guys. If you went through those and you had more questions about something, um, I think I missed one out of those, or some of those I didn't check. If you think maybe when I went through it, I didn't check it good enough or I didn't do it, just let me know, man. I've been getting quite a few emails from you guys. Some of you guys I haven't heard a thing from. I'm upset, man. Some of you guys I haven't heard a single thing from. And some of you guys used to come see me all the time. You came to my seminar or my flexes just because you wanted to. And I haven't seen you. I haven't done nothing. I've done nothing to you guys. I miss you guys. Come on, man. Just say hello. How you doing? You know, I didn't get to say my goodbyes to you guys or anything else or like that. And it's kind of sad. It sucks. Sorry, I probably shouldn't say that, especially on a video. I need to probably cut that out. All right. Hey, have a happy Friday, guys. Again, I'm going to be looking at some things and try to get us going to reviewing. We're going to have to step it up a little bit more. I don't want to give you guys a whole lot, though, because I just don't want to. But I want to make sure we get enough reviewing. We got to hit first semester at some point. So we got to hit first semester at some point. And just, again, to get us mind thinking on a lot of those topics. So here we are, man. Have a great Friday. Again, please contact me if you need something. I am going to have a Google form for you guys to fill out. It's not required or anything else. Again, this is for information for me to try to help you guys what will be beneficial for you to help you study for this AP exam that you guys are going to take. You're going to get the college credit if you pass it. And guys, there's only 2 questions. Now, you can maybe turn that as a positive. You can turn that into a negative. But there's only 2 questions. You get them right, you're going to get college credit. That's going to save you some money. Let's do this, okay? Let's do this. You guys are going to find out that y'all are going to be okay, all right? So let's just do this. Everybody in this nation is in the same boat you are, except one thing. They didn't have me. Sometimes you gotta just state a fact. I'll tell you this much. That probably is a bad statement, but I'll tell you what, they dang sure don't care about you like I do. All right. Have a great weekend. We'll see you.